Everyone, so today we are going to go over patterns and nonlinear functions. So the first thing that we're going to do is just decipher the difference between linear and nonlinear. So as you can see, there's the word line in a linear function, right? You see the word line, and that's exactly what it means. All of the graphs that are linear functions are in the shape of a line. So the way we're going to define this, you're just going to write this right under linear function, is a graph. Let's see if I can write tiny. A graph that is in the shape of a line. Okay? Now, on the flip side, a nonlinear function is a graph that is not a straight line. So we can write under here a graph that is not a straight line. Okay, and we can clearly see the difference, right? These top three are all straight lines, and these bottom three are not straight lines. This one on the right, it kind of looks straight, but then it comes back up another way, and it is not straight. Okay, it's like a V. So as long as we can see the difference between linear and nonlinear, we're good for right now. So the first example that we're going to do is the problem says that the area A in square inches of a pizza is a function of its radius r in inches. So that talks about this table right here. Then it says the cost C, so now we're back over here, in dollars of sauce for pizza is a function of the weight. So it wants us to graph these functions and then decide if it's linear or nonlinear, okay? So the first thing that we're going to need to do is label our graph, okay? So this first graph we're going to use for this first table right here, and this is pizza area. Pizza area, okay? Now, our x-axis is going to be the thing that is our independent variable, which is our radius. And then our y-axis is our area, because our area depends on what our radius is. So this is just going to be a very rough sketch because we don't have graph paper right now. So I'm going to define, we can see that our radius goes from 2 to 10, so I'm just going to count by 2's. So we know we start at 0, 2, 4, 6, 8, 10, 12, 14. Okay? So this is counting by 2's, so I'm just going to write a 2 for the first one. Now, I'm going to count by, see, it looks like we're going all the way from 12 to 300. So I'm going to count by 50s. So here we have 50, 100, 150, 200, 250, 300, and so on. So I'm just going to define that as 300 up here. Okay? So now I'm just going to plot my points and see what we get. So it says that when my radius is 2, my area is 12.57, which is going to be somewhere around here, pretty low. Then when my radius is 4, my area is 50, so I'm back up here. When my radius is 6, my area is 113, so this was 100, so a little bit further up than that. When my area is 8, I'm at 200, so I'm all the way up here. Then when my area is 10, I'm all the way up at 314, which is going to be somewhere up here. So if we were, now, let's see if I can do this. If we were to connect all of those dots, that's pretty good. Does that look like a line to us? It's curving, definitely curving. So this is going to be a nonlinear function because it's not a straight line. Still a function, but it's a nonlinear function, so it's not a straight line. Okay? Now I'm going to change my color, and we're going to test out what our sauce cost is going to be. So I'm just going to move this up a little bit. Okay? So now, again, we label sauce cost. Okay? Now, my independent variable is our weight. And my dependent variable is the cost, because the cost depends on how much our sauce is weighing. Okay? So again, it looks like my weights are counting by 2s, so I'm going to start at 0, and I'm going to go 2, 4, 6, 8, 10, 12. Okay? And then it looks like my cost is only going up to $4, so I'm going to count by 2s as well. So, actually I'm going to count by 1s. 1, 2, 3, 4, 5. Okay? So let's just start plotting our points. When our weight is 2 ounces, our cost is 80 cents, which is less than $1. So we're somewhere down here, right? When our weight is 4, we're at 160, which is going to be right in between 1 and 2. When our weight is 6 ounces, we're at 240, so somewhere right here. When our weight is 8 ounces, we're at 320, so close to right here. And when our weight is 10 ounces, we're at $4, so right here. So if I were to, now again, this is a rough estimate, but we can definitely tell. So if I were to connect these, now my line wiggled a little bit, but it does look like a straight line. It looks like it's a constant rate of change. So this is going to be a linear function. Linear function. Exclamation point, okay? So all we have to do to figure that out is to graph it and see what we're looking at. Okay, so next up, I'm just going to move that over there. It says that the table shows the number of blocks in each figure as a function of the number of blocks on one edge. What is the pattern you can use to complete the table? Represent the relationship using words, an equation, and a graph. Okay. So when we were working with linear functions in the last video, we looked at our y's, and we wanted to see where if we had a constant change. So if I'm going from 1 to 8, that's adding 8, right? And if I'm going from 8 to 27, that's adding way more than 8. So I know that it's not a constant change. So I know that instead of looking at the changes in y's, I'm going to look at how I can go from my x value to my y and see if we can find some sort of pattern. So when I go from 1 to 1, there's many, many things that this could be, because 1 is one of those numbers where you can do many things to it and multiply it to itself so many times and you still get 1. So we're just going to skip down to 2 and 8, and we're going to see if we can figure out how we get there. So if I just look at 2 and 8, I know that I multiplied 2 by 4 to get to 8, right? Now let's use this same pattern down here. What do I multiply 3 by to get to 27? Well, that's 9, right? So is there a way that I can represent 4 and 9 in a different way? Yep. 2 times 2 times 2 gives me 8, correct? And this is where that 4 was. Now down here, 3 times 9, but I can represent 9 as 3 times 3, and this is where that 9 was. And I get that 27. So it seems to be that you're multiplying however many blocks are on the edge, whatever this number is, to itself 3 times. So the way that we can represent that is we can say that it's going to be x to the 3rd power equals y. Because what's happening is that when I take this block on the edge and I plug it in for x, I get 3 to the 3rd, which gives me 27. If I plug in 2, I get 2 to the 3rd, which is 8. If I plug in 1, I get 1 to the 3rd, which is 1. And that's exactly what we want. So now we want to follow this pattern down, and we can plug in 4. So if we plug in 4 to the 3rd power, that's 4 times 4 times 4, and we end up with 64. Now it's tiny. So our coordinate point is 4, 64. Now if we do the same thing down here, we do 5 to the 3rd power, we're going to get 125. So that coordinate point is 5, 125. So as we can see, if we want to explain this using words, we already got our equation. If we want to explain this using words, we can say that the total number of blocks, y, is the cube, that's where that 3rd power comes in, of the number of blocks on the edge. Okay, so as you can see right here, this is the number of blocks on the edge are 3. So what you're doing is you're doing 3 times 3 times 3, and you're getting basically the volume of that big figure. So now we're just going to graph it quickly, and we're going to see if this is linear, okay? So over here, we can label this as number of blocks, okay? And I'm going to do this in a different color so we don't get confused. So down here, my x value, this is number of blocks on edge. So blocks on edge. And then on this left-hand side, my y-axis, this is total blocks. Okay? So I know we start at 0. Now my number of blocks is, it's just going up by 1. So 1, 2, 3, 4, 5. And my y's, they're going up like very quickly. So I'm going to start, I think I'm going to count by, let's do 25. So I get 25, 50, 75, 100, 125. Okay? So 1 and 1. I have 1 block on the edge and I have 1 block. So I'm somewhere down there. 2, when I have 2 blocks on the edge, I have 8, which is going to be somewhere over here. 3 blocks on the edge, I have 27 total blocks. 4 blocks on the edge, we figured out that I have 60, so we're going to be somewhere over here. And then when 5 blocks are on the edge, I'm all the way up to 125. So as we can see, this is not a linear function. So this is a nonlinear function because it curves up. It grows super quickly. As our number of blocks on the edge get larger, the total number of blocks blow up, and there's so many. Great job. So lastly, we just have one more problem. We have the ordered pairs, 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. And they represent a function. So it wants us to figure out a rule that represents this function. So when it says a rule, it really wants an equation. So the way that I like to write this out is I like to make a table. So we have x and we have y. So I have 1, 2, 3, 4, and 5. And we go to 2, 4, 8, 16, and 32. So again, we like to look at our y's and we like to see how are we changing and is it constant. So from 2 to 4, we add 2. From 4 to 8, we add 4. From 8 to 16, we add 8. From 16 to 32, we add 16. So there's no constant change, but I do see a pattern. Whatever our y is, we're doubling it, correct? So we want to figure, it has to do with something with 2. We're multiplying it by 2, aren't we? So what we need to do is we need to look at the difference between our x's and our y's, and we need to see what needs to happen. So it's a kind of similar to the last problem as we're using this x value. So let's just take a look at 3. What can I do with 3 to get to 8? Well, I know that in the last problem we multiplied 2 3 times to get to 8. So we can represent this as as 2 to the x power. So we're multiplying 2 to the 3rd power, which gives us 8. 2 to the 4th power gives us 16, and so on. So our equation is going to be y equals 2 to the x power. Now, it takes a lot of practice. It takes guess and check to get this right, but it's all about exploring these numbers and figuring out what you have and how you can get there. So try this last one on your own and keep it up, guys. Come to class with questions.